Okay.
Yes.
What we have discussed in last class, the per unit conversion for three device, like this was the last topic. To determine Z per unit new or two, right? Based on some diagram like this, right? That was the last topic we have discussed in where we have three device, right? Three device to consider.
Yes, sir.
Now today we will discuss slightly complex network than that, based on the earlier concept. This time the network is of how many components? How many components do we have there now?
Sir, 6 with the load 7.
7, right? 7 means actually you have to consider static load as well, right? And how many bus are there?
2 bus.
Actually, this is one bus.
Oh, no, my bad, sir. My bad. No, sir. Yes.
That
6
means
bus.
6 bus total, right? So one generator, two load. That this is the static load, and that one is the motor load. So you have two types of load, and one
Yes.
generator as source, and the 4 transformer. So total 7, right? And 6 bus. Beside that, you have two line arrangement. Line 1 has 220 kV and line 2 has 110 kV. Okay. So if you can recall the last class idea to shift the per unit, for this case, the per unit conversion should be based on, actually here it is the chart, that is the information given for the component, and for generator you have capacity as 90 and voltage as 22, and per unit reactance or impedance is 18%, right? 18% means 0.18 per unit domain. So can you determine that capacity generator per unit impedance in 100 MVA base? 100 MVA base is the new base now. Okay. Try to find all the per unit reactance in 100 MVA base. New base SB2 is 100 MVA now. If you can understand this problem, the last class lecture, okay, based on the same concept, try to find uh, the per unit equivalent, okay, and give the response in the chat box. Can you recall the last equation or do I need to show? You have the last expression, right? Based on which you can find the.
So can you write it down? Okay.
You have done the per unit equation. This one was the per unit equation. Okay. You can rewrite that equation so that it is not there. Last class though it was there, but as you have started, you can rewrite that equation once again. Z per unit 2, only this one is required. This thing you have to write once again. Z per unit 1 into VB1 over VB2 whole square by into SB2 by SB1. Based on that formula, you have to determine the per unit reactance in 100 MVA base. New SB2 is 100 MVA now. 334, you need to check the equation, okay? What you have chosen as base. And regarding the base information, actually try to consider the generator base, the initial, what is the base voltage of bus 1? What should be? First of all,
22, sir.
right, based on generator voltage, right? 22. So what about the base voltage of bus 2? 323 is not correct. So what about the base
220, sir. 220.
220, right? How can you take that decision from T1 stepping, right? T1 is transformer turns ratio.
Yes, sir.
So what about base voltage of bus 3?
So 220.
Right, because you don't have any component in between them. What about base voltage of bus 4?
Sir, that's 110.
110?
No, sir, wait.
Try to check T2, right?
11, sir. 11.
11. Right. 11 kV is the base voltage of bus 4. Likewise, you can find bus voltage of base voltage of bus 5, right? What should be base voltage of bus 5?
Yes, sir. So that's 110.
110, right? So in this way, you can first identify all the base voltage. Base voltage are different, but capacity is same. That means base capacity, where you have to consider it will be 100 MVA for all the time.
100.
Right. So if you just
আমি ওভাবে করছি স্যার আমার
I'll try to check once again. The equation, I think, let's check the equation. Z per unit. What you have taken as VB1 or 2? What is your VB1?
So both are 22.
Right.
Both are 22.
So SB1, what you have chosen
For
as
G.
SB1? SB1 for G. What is SB1?
Sir, that's 90. Oh, that should be 100 and the other one should be 90.
Right. That's why it's not correct. SB1 should be 90. SB2 is 100. Right? Okay.
Yes, sir. I made a mistake. Sorry, sir.
323. You have to check. It is not correct. 323. Now it's correct, 334. So in the same way, you have to find all the other per unit reactance, okay? Try to determine all the per unit reactance based on the same concept for T1, T2, T3, T4 as well as motor load M. T23, now it's okay. $336, Sabrina, are you there?
Yes, sir. Assalamualaikum,
Okay,
sir.
have
I'm
you
calculating,
determined?
sir.
Okay, fine. Have you determined G?
Yes, sir. It's point. Sir,
Okay, you have to write that answer in the chat box.
Yeah.
323. T1 is not correct. Try to check. 323. T2 is not correct. What you have taken? T1 is there, 334. T1, have you applied the same concept like T1? T1 was correct, but T2 not.
Yes, sir.
T2 is not correct.
Yes, sir. Okay, sir. I'll check it again. Sir.
Check that. 315. T1 you have to check. It is not correct. 315 T1. 315. Can you hear me? What you have chosen as X Z per unit 1? 315.
Sir, I can hear you. Can you speak a bit? I can't hear you really. I mean,
Okay, 315. Try to find
can you
what
join
you have.
me again and leave, sir? I can't hear you. Can I join the meeting and again? For now, can I leave?
Okay, you
Because
can
I can't hear
rejoin.
a thing.
You can rejoin. Actually,
Okay, sir. I'm gonna
I
rejoin.
think I have made some co-host. Mariam, are you here? T36, ZT1, ZT2 is not correct. What you have selected as X uh, Z per unit 1, 336,
Yes, sir.
Z per unit 1. What you have selected as T1
Sir,
or T1?
18%, sir. 18
10,
by T1, sir, 10%.
10% means what is the Z per unit 1.1, right? So
Yes, sir.
I think you have made the calculation for which side, HT side or LT side. If it is LT side, you have to choose base voltage accordingly. Otherwise, the problem will be earlier case, like base voltage should be chosen as the voltage given. So voltage does not have any impact to the equation. I think you have mixed
Okay,
VB1,
sir.
VB1 and VB2. What you have chosen, it is different. It is not. It should be same. Okay. VB1, VB2 will be same. If you choose HT side, in that case, all of them will be 220. If you choose LT side, VB1 and VB2 both will be 22. T34 per unit and percent impedance, they are different. Okay. If it is per unit, in that case it should be fraction. If it is percent, in that case it should be the total number. I think you have got my point. 334.
Sir, I have sent you writing the unit as PU.
Not pu is pu. If it is like this one, pu should be fraction. Okay, in fractional value. And if you write
Yes.
that in percent, in that case it should be, I think, correct. Percent impedance and pu
Sir,
impedance, there
no,
is
sir,
some
I didn't write them in percentage.
it
Sir, I
is
didn't write them in percentage. I write them in
that's why I have understand that you have to be careful about that. Okay.
Yes, sir. Thank you, sir.
Mhm.
Sir, are those answers correct, sir?
I think in percent value it is correct. Percent level it is correct. Okay, many of you have tried to find that actually what should be like that. That means Z, the generator per unit equivalent is 0.2, transformer per unit equivalent A new per unit equivalent is 0.2 as well. Transformer 2 is 0.15, transformer 3 0.16, and transformer 4 it is 0.2. Whether your results satisfy this one or not, try to check.
Sir,
Yes,
these are for voltages, sir, or these are for
these are for
so the
impedance. Okay, all are in per unit impedance.
actually, yes, sir. Maybe I am wrong, sir. I followed the equation that PU is equals to ZPU1 into
Right.
VB1 by VB2 into SB2 by SB1.
That's
Sir,
okay.
here, where are the VB1 by VB2?
Actually, VB1, VB2 are cancelled by each other. That's why that part is 1, and 1 multiplication factor will not
Oh,
have any impact for
sir,
this point. If the value of voltage is different, in that case, it will have impact. You can put that value and cancel, okay?
yes, sir.
The general equation is to put the value.
Sir, I think,
Yes.
yes, sir. Sir, I think the thing I did was like sir, can you go to the previous page, please?
Okay, fine. This
Sir,
one.
can you hear me?
Yes. Who is there? Okay.
Sir, Marshad said he couldn't join the class right now. He has network problem.
Okay, you
He
can
told me to.
okay, you can manage the system. Actually, one of student like Suha has some problem, and
I just joined.
okay,
Sir, I just
okay.
joined. I
Now it's
think
okay. Now it's okay. Okay, fine. The volume or the
sir,
sound is okay. Is it
sir, I can hear your sound, voice twice or thrice. That's the problem. I can't really get it.
now also this
Maybe
is the
I'll.
problem? From my side, it's not the problem. Do you other one has the same problem?
No. It's from my side.
Okay.
It's from my side, I guess. Okay, no problem, sir. I'm trying to follow the class. It's okay.
স্যার আমি হচ্ছে যেটা করছিলাম আমি VB1 আর VB2 হচ্ছে দুইটা ডিফারেন্ট ধরছিলাম যেমন স্যার আমি T2 এর জন্য যেটা করছি T2 এর জন্য আমি হচ্ছে VB1 ধরছি 220
Okay,
আর
fine.
হচ্ছে VB নিউ যেটা ওটা ধরছি
VB2.
22 যেটা আমাদের কোশ্চেনে দেওয়া ছিল
No.
জি স্যার যেটা কোশ্চেনে দেওয়া ছিল 22
Actually, when you consider T2 is the when you are in this place for T2, you have to consider base voltage of bus 3 or bus 4. Okay, the initial voltage is for bus 1. When you switch all the okay from position to position, your base voltage
yes
should
sir
be
I get it
different. Base voltage should not be the same as the earlier position. It should be
so
different
the
for
base
different
voltage
location.
will be different sir
Different, right? That's why I have asked
yes sir
at first
yes sir
that
I
what
get
should be
it
base
sir
voltage of bus 3.
yes so that's
That's
the
why I
my
applied bus 3
different
base
thank you
voltage.
sir
Okay. So I think others have 336. What's your problem? 336.
Sir, can you scroll down?
Scroll down or up? This one?
Down for the aim, the value of aim. No, sir. I was
Value of M.
checking my
Okay.
answers,
Okay.
so I couldn't see.
Actually, ZT1, ZT2 you have done is not correct. That's why I have asked you that what you have done.
No, sir. I had some problems. I took the V1 and V2 different, so I had zeros coming.
Yes, sir. I
Yeah.
also made the same mistake.
Right. That's
It's
the
gonna be 0.2, I guess.
right 0.2. Actually, if you have to consider
Okay.
voltage as base voltage as the reference voltage or the given value. Okay. For capacity only you have to shift
Yes.
the SB1 and SB2. Voltage will be same if it is not different. Only for motor case you can see motor is attached to which bus? Bus 4, right? And what is
4.
the base? Yes. What is the base
Yes.
voltage of bus 4? What should be base voltage of bus 4?
110.
It is actually done.
110.
No, it is actually attached to T2 secondary, right? What is the T2 secondary?
Oh, it's broken. 11 kV.
11. Okay, so bus 4 base voltage should be 11. But what about motor rating? It is 10.45. Okay. In that case, VB1,
10.45.
right. In that case, VB1 and VB2 will be different, not same, like the earlier other bus. Only bus 4 has VB1 and VB2
Okay.
different. Okay.
স্যার তখন কোনটা
VB1 will be the given
Then
value.
VB1 will be 11 kV
10.45.
or
No, VB1 will be 10.45.
10.45.
The given value of the device, and reference value will be 11. That means you have to switch that value to 11 kV, which is VB2. Okay. For motor, if you just make the calculation, it will be clear to you, because it is
Sir, can
different.
you please repeat it
For
again? I'm
motor
getting
case,
confused.
for motor case, what
Yes,
should be VB1?
sir. So 10.45.
Right, because it is already given. And what should be VB2? Like the earlier case, it will not be the same. Earlier case, the voltage given and the base voltage are same. But for bus 4, base voltage is 11, but given value is different. Okay. That's why VB1 should be 10.45, the given value. And you have to shift that value to 11 kV, the base value. That's why this value will be VB2 will be 11. Okay. I think you have got my point.
স্যার আই হ্যাভ আ কোয়েশ্চেন স্যার
Yes.
যদি এমন হতো স্যার T3 এর ক্ষেত্রে যেটা ভোল্টেজ দেওয়া 22/110 ওটা ওভাবে দেওয়া আছে, বাট T4 এর ক্ষেত্রে হচ্ছে যদি 110 না হয়ে
কোনটা কোনটা কোন পজিশনের জন্য
স্যার
বলছো?
স্যার হ্যাঁ
ট্রান্সফরমার
T3 স্যার T3
T3, ওকে, হ্যাঁ T3, yes,
ইয়েস স্যার ট্রান্সফরমার T3
হ্যাঁ।
T3 তে হচ্ছে কি আমার 22/110 দেওয়া,
রাইট।
আর T4 এ হচ্ছে 110/11। যদি এমন হতো স্যার যে 22/110 ঠিক আছে, কিন্তু T4 এর ক্ষেত্রে 110 না হয়ে 115 or 120 এমন দেওয়া, স্যার এমন কি দেওয়া থাকে? আর সেই ক্ষেত্রে VB1 কোনটা হবে আর VB2 কোনটা হবে?
VB1 will be the given value. যদি এরকম থাকেই তাহলে তোমার যেটা দেয়া থাকবে সেটা হবে given value, আর যেটা তুমি ইয়ে করবা মানে বেস ভ্যালু হিসেবে নিবা সেটাকে ধরবা নেক্সট ভ্যালু, মানে তোমার VB2 হিসেবে। 110টা হবে তখন বেস ভ্যালু VB2, আর VB1টা হবে যদি ডিফারেন্ট ভ্যালু থাকে। সাধারণত থাকার কথা না, ট্রান্সফরমারে থাকবে না, মোটরে থাকতে পারে। মোটর সেটআপ অনেক সময় অ্যাডজাস্ট করে না। মোটরের ভ্যালু sometimes you have different rating than the rated voltage or rated current, or the value of the motor may not have the same rating or the same capacity which is required. Okay, so you have to adjust that motor because it is load. Okay, the system is fixed, but motor or the load, it may be different because it can be isolated from the system, right? That's why the rating of motor is not the standard rating. But for other device,
Yes, sir.
they are
Yes.
actually fixed system. So system parameter may not have different response, but if somehow if it was there, it is not in general practice, but if it is there, in that case the given value should be considered as VB1. Okay, but for motor it may happen, motor or load, it may happen that the voltage will not be the same as the bus voltage.
Yes, sir.
Because loads are connected based on the customer requirement. It may not have the same like the system requirement. So when you consider the motor part, the motor calculation will be something like that. That means this will be the VB1 and VB2. Okay, and they are different. And this is the general equation, the regular equation to shift your per unit to new domain. Okay. For other equipment, as the voltage for base and the regular value is same. That's why that part is omitted because they are same. But for motor, it is different. That's why you have to consider that. So it's better to write the general equation and then if it is same, you can cancel that part. Better to use the general formula. Now, the last part that you have to consider also the line information. Actually, regarding line, the value is given, the impedance of the line or reactance is given in terms of actual value, right? Ohm is there. That means this is the actual value of the system, the line impedance or reactance, right? So how can you address the line per unit? First of all, as it is given in actual value, you have to consider the base impedance of the line, right? And to address that base impedance, we know how to find base impedance from the capacity and voltage. ZB relation in terms of capacity and voltage, the very basic or the general equation. ZB can be VB square over SB, right? The basic equation to determine the base impedance value. When we can find ZB for line 1, what should be ZB? Line SB, what is the value of SB for line 1?
That's 90, sir.
Line 1 SB, not 90 because it is actually 100 MVA base, right? Common base is 100 MVA. The device may have different rating, but common base for the system now is 100 MVA. So VB square over SB, VB for that bus 2 is 220 kV, right? Bus 2 kV, 220 kV. So VB square over SB will give you ZB. Okay. So ZB1, ZB2 will be determined based on VB square over SB, right? Okay, fine. 336 correct. So this is the base value. So if you have the base value and you know already the actual value, you can find per unit value of the line 1. Line 1 actual value is there and ZB1 is actually line 1, ZB line 1, right? So ZB line 1 and line 2 after per unit solution, you can get something like that. Okay, ZB, this is the actual value of the line and this is the base value of impedance for line 1, which is attached to bus 2. Okay, that's why it is ZB2 written. And this is attached to bus 5, that is ZB5. So this one, the last part, actually we have already discussed about the 4 transformer per unit equivalent, motor, generator. The remaining one, the load. This is the important factor to consider. Regarding load, what is given there? Load, 3-phase load is attached to bus 4, which has capacity 57, lagging power factor of 0.6 and the voltage for that 10.45, right? So to address that, first of all, you have to use the impedance equation, the VLL square over SB conjugate. Okay, that's the equation or formula you have to use to determine the load ZL, load impedance. Okay, this is the equation you have to remember. For 3-phase system, if you just want to find the load, you can use this formula. Okay, for 3-phase. and the value is actually line to line, which is 10.45. Okay, and SL, as it is lagging power factor, that means which types of load it is? It is the inductive type load, right? That's why it is positive. And this, there you can see the equation for load impedance. It has SL conjugate for three-phase system. Okay, so SL regular for 0.6 as 53 positive, but here it is SL conjugate, that's why it is negative. Okay, this will give you the response in positive reactance, which is inductive reactance, and that satisfies the condition of lagging power factor. Okay, this part you have to remember. This is one important relation. Is there any confusion up to this point, especially for load impedance determination?
The value of SL, is it given?
Right, 57 kV, it is all MV, it is already there. Value of SB in capacity is there. It is the question. Okay, three-phase load, bus 4 absorbs 57 MVA. This is the capacity, load capacity, and this is the power factor, 0.6 in lagging power factor. Okay. So when we determine that ZL, what about Z per unit? Z per unit can be determined, ZL per unit actually from Z base 4. Actually base 4 has the, what is the ZB for 4? It can be determined like SB, VB square over SB, right? For 4, bus 4, this is bus 4, the VB for bus 4 will be what? From T2 secondary. T2 secondary is 11. So VB is 11 and SB is 100 for the total system, SB capacity. So 11 square over 100 will give us the ZB for bus 4, which is 1.21, right? So just now what we have got, this is the impedance in actual value, ZL in actual value. And this is the value in terms of base value. So we can get per unit impedance by dividing actual value over base value. It is per unit. Z load impedance in per unit. Okay. So when we have all the value in our hand, the main target to determine the per unit equivalent is to draw impedance diagram based on per unit information. Okay, this will be the ultimate objective of the derivation or conversion of for per unit. Actually, how can we draw that diagram? That's the main objective. When we have the all the information, what about per unit of generator? That one was 0.2, right? 0.2 per unit for impedance, and generator are connected in series with the impedance. That's why this is the generator internal impedance 0.2, which is generator per unit equivalent impedance, and it is connected to bus 1, right? After bus 1, what we have?
Yes, sir.
T1. T1 per unit equivalent impedance was 0.2, which we have determined, right? 0.2 per unit for T1. Then line 1. Line 1 has 0.1. Then T2. T2, when we have made the calculation, it was 0.15 per unit. So line 1 has this element, line 2 has T3, line 1, line 2 and T4. The equivalent per unit impedances are connected in series. Then after 4, we have two load. One is motor load, motors as well as the generator. It is in series. The motor equivalent reactance, which is 0.25. And load regarding load, as the per unit load impedance is there 0.95 and 0.16, 1.26 per unit, that is connected like this. The resistance and inductance. Say for example, if it is negative, what you have to do? After calculation, you have got the value of ZL per unit as negative, something negative J. In that case, you have to draw the diagram accordingly. Instead of inductance, you have to put capacitance, right? You may have capacitive load as well based on power factor. As the problem suggests, the power factor is lagging, you have the inductive load. If it is leading, in that case, it should be capacitive load. Okay. So, is there any confusion to draw the per unit diagram from the information? This is the important topics to convert the per unit information from the single line diagram. The diagram, this diagram is known as per unit diagram. Okay. Per unit diagram, impedance diagram, per unit impedance informations are there. What was the diagram we started? This diagram is known as single line or one line diagram. It consists of the symbolic notation, right? The transformer, it is in symbolic notation instead of value. This is one line diagram. Okay. So if the informations are given like this chart and the symbolic notation, the diagram will be considered will be one line or single line diagram. From the single line diagram, we have to shift the diagram to one line diagram. Okay. Oh, sorry, per unit diagram, per unit impedance diagram. This is the per unit impedance diagram. Is there any question or anything to ask? It's one important topics. It is the base topics to address this course. To shift any information to equivalent per unit impedance information or per unit impedance diagram. Okay. Next, if you don't have any question, we can proceed further. The motor, if the motors operated has leading power factor. Initially, the motor configuration was 0.6 lagging, but now if it is leading, how can we address that? The leading power factor motor, actually load was lagging, but motor has leading power factor. So how can we determine generator bus voltage as well as generator and motor internal EMF? For first scenario, what is the per unit information? As I have mentioned, V4 base voltage will be determined based on 10/11. This is the per unit for bus 4, right? Is it okay?
Yes, sir.
Okay. Then we can consider the motor scenario, which is leading power factor. Leading power factor S will be negative. Okay. Lagging power factor S was positive. Leading power factor angle for S will be negative. Remember that. And regarding 16, this is the information of the motor. Okay, motor information. Earlier it was given. There you can see the motor capacity. Okay. So another thing to determine the current. The current information can be determined. This is the current, voltage, and capacity relation. Can you recall the capacity basic equation? What was that? It was something like S equals V into I conjugate, right? But for this case, the conjugate informations are transferred to other side. That means I conjugate, it is removed, and other components has conjugate information. So from the calculation of S, as it is negative, the conjugate information will be positive. And V4, it has not any impact because of 0. So IM we can find in the same way. We can find IL for V4 over ZL, and that can be determined based on this. ZL is the value in per unit domain. V4 is value in per unit. All the values are in per unit, so IL is also in per unit. And after KCL application at node 4, we can get the total current. Total current will be something like that. When we consider that circuit, this is actually parallel branch, right? So parallel branch, the first line has 0.2, 0.3, and this is 0.45, right? When we add those all the three components. For second line, 0.54, that means 0.7, and this is 0.9. So 0.45 and 0.9 are in parallel configuration, two lines. So there it is 0.45 and 0.9, they are in parallel configuration, and it will give per unit as 0.3. So after equivalent impedance, we can get the terminal voltage for generator in terms of load bus reference voltage. Load bus voltage was 0.95, and this is the current, this current, the total current for motor and load, and this is the equivalent impedance for the line. So if we just consider the load side, load plus drop will give us source. This is simple. What is that? KVL equation, right? The KVL formation to get the source voltage in terms of terminal. So when we make the calculation, it will be based on 1. Okay. That 1, after that 1, we need to shift that for actual value by multiplying the terminal voltage of bus 1, which is 22. That means the actual value for the generator terminal will be 22, like that. This is in per unit, this is in actual value. So up to now, is this clear? How we can determine generator terminal voltage from the load voltage, load bus voltage? Is it okay?
Yes, sir.
Okay. So now the other part, to find the internal EMF. This is the terminal voltage. Okay. The internal EMF will be actually you have to adjust that for internal EMF. If it is terminal voltage, that means this part is there. That means this is the terminal voltage of generator. Now we want to find the internal EMF of the generator, considering the impedance notation. That means if we just want to find that, we have the information of that node, we have to add this value to get the internal EMF of the generator. Terminal voltage V1 is already determined. We want to find the internal EMF of the generator based on terminal voltage. Okay, terminal voltage plus the drop in the inside the generator I and ZG. This is the per unit impedance for the generator internal inductance. So we can get EMF for the generator, right? And that you have to multiply with the base voltage of the bus 1, right? Base voltage of the bus 1. And for motor, here you can see the motor is connected to bus 4, and this is the minus IMZM. Actually, why it is negative? Why it is negative? The motor, for generator, what we have seen, it is positive, right? For motor, it is negative. Actually, the current polarity will decide the matter of negative sign. Okay. So what about the bus 4 base voltage? Bus 4 base voltage. What is the base voltage of bus 4? The base voltage of bus 4 will be determined from T2 or T4 secondary terminal, and that is 11 kV, right? So 11 kV, after calculation of the per unit, you have to multiply that information with, this is the per unit information, it is multiplied with 11, not by 22, based on the position of V4. Earlier one, it was V1. Okay. So this is all about how we can address the terminal voltage calculation as well as generator internal EMF as well as motor internal EMF from the per unit equation calculation. Okay. So is there any question from that part? If it is not there, we can proceed further. This is one problem based on the concept what we have discussed just now. You have to draw one impedance diagram for the electric power system given in the this one. There, this is the diagram. This is the single line diagram, right? It is the transformer in symbolic order. So the base voltage for the system should be considered a capacity. Capacity should be 100 MVA, and 20 kV will be generator base voltage. Okay. So if generator base voltage is 20, in that case you have to find the base voltage of other part of the system based on the location. So the information for the generator 1, transformer 1, 2 and generator 2 is given, line information is there and load information as well. So try to find the per unit impedance for all the six quantity, right? Can you find the quantity based on the problem what we have just discussed?
Yes, sir.
Okay, one announcement I need to declare. Uh, we can we take quiz or class test next week? What is your schedule? Mariam, are you here?
Uh, sir, after 13 October, already 11 and 13 is booked.
11 and 13 booked. Okay, then next week, that means after that week, maybe 19 will be okay.
Yes, sir. Okay.
Okay, fine.
Syllabus?
Syllabus will be covered by today or
Sir,
yes,
what syllabus?
yes. Another thing, I will give some assignment and it will be due on that
Okay, sir.
day. That means before 19 you have to submit. Like
Hello,
that.
sir.
Yes.
স্যার অ্যাসাইনমেন্টের ডেডলাইনটা একটু মানে একদিন বা 2 দিন পরে রাখা যায় না, কারণ কুইজের কারণে যদি পড়ে বেশি না, যদি 19 20 এভাবে।
আচ্ছা, 19 will be the quiz date and 20 will be assignment. Okay. Actually, assignment practice should be earlier. That's why it is given the deadline as like that. If you submit assignment late, in that case, it will not have the impact on the quiz. Or if you practice later, you will miss the quiz bonus. So assignment will be 3.13.
Hello.
Yeah, who is there?
Yeah. Hello, sir.
Who is there? Excuse me. What's your ID?
It's Ibrahim.
You have not mentioned your ID.
Oh, sorry about that. My ID is
স্যার অ্যাসাইনমেন্ট হবে,
Assignment deadline will be
তাহলে
19 actually. It's better to submit 19 by 19. Okay. Otherwise,
ওকে স্যার।
assignment will be relevant to this topic. That's why you have to submit 3.13 to 3.16, 17, 3.17 up to 3.17. Okay. I will give
Sir,
that.
this is the Haditha book, right?
Right.
This is
3.13
from
to
the Hadith Sadar.
3.17. Right. 3.13 to 3.17, excluding 3.14. Okay. Exclude 3.14 only. 3.13 to 3.17. So when you complete the job of per unit calculation, you have to draw that accordingly. So I think you have got the point how to address that issue. Syllabus will be up to this week. That means this topic, per unit diagram, impedance diagram conversion. We can determine the per unit equivalent impedance diagram. Okay. So 19 will be your class test day. Okay, fine. Okay. Thank you all for attending today's session. If you don't have any question, we may conclude today's session. Okay. And thank you.
Hello, sir.